Hello everyone. Today I am going to give presentation on a machine learning technique which is ridge regression. So what is ridge regression? Ridge regression is a modeling technique that works to solve the multi-collinearity problem in OLS models through the incorporation of the shrinkage parameter, that is lambda. The assumptions of the model are the same as OLS. Linearity, constant variance and independence normally not need to be assumed. Additionally, multiple linear regression OLS has no manner to identify a smaller subset of important variables. Mathematical foundation of ridge regression. In OLS regression, the form of the equation y equal to beta naught plus beta 1 x1 plus beta 2 x2 plus dot 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 e can be represented as xt x beta equal to xty, where x is the design matrix having xij equal to xi and y is the vector of the response y1 and y dot 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 yn, and beta is the vector of the coefficients beta 1 and dot 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 beta n. This equation can be rearranged to show the following: beta equal to x dash x whole raised to the power minus 1 into x dash y, where r equal to x dash x and r is the correlation matrix of independent variables. Here is the rearranged OLS equation again from the previous slide. Beta equal to x dash into x bracket whole raised to the power minus 1 into x dash into y. These estimates are unbiased, so the expected values of the estimates are the population values, that is E into beta dash equal to beta. The variance covariance matrix of the estimates is V into beta dash equal to sigma square into r raised to the power minus 1. And since we are assuming that the y's are standardized, so sigma square equal to 1. Ridge regression proceeds by adding a small value of lambda to the diagonal elements of the correlation matrix. This is where ridge regression gets its name, since the diagonal of ones may be thought of as ridge. So equation is beta equal to r plus lambda I bracket whole is to the power minus 1 into x dash into y. Lambda is a positive value less than 1, usually less than zero point 0.3. The amount of bias of the estimator is given by E into bracket beta dash minus beta bracket close equal to bracket x dash into x plus lambda into y bracket close whole raised to the power minus 1 into x dash into x minus 1 bracket close into beta, and the covariance matrix is given by v into beta dash equal to x dash into x plus lambda I bracket close whole raised to the power minus 1 into x dash into x dash into x plus lambda into y whole raised to the power minus 1. One of the main obstacles in using the ridge regression is choosing an appropriate value of lambda. The inventors of ridge regression suggested using a graphic which they called a ridge trace. A ridge trace is a plot that shows the ridge regression coefficients as a function of lambda. When viewing the ridge trace, we are looking for the lambda for which the regression coefficient have stabilized. Often these coefficients will vary widely for smaller values of lambda and then stabilize. Choose the smallest value of lambda possible, which introduces the smallest bias, after which the regression coefficient seems to have remained constant. Note, increasing lambda will drive the regression coefficients to 0. Here is the ridge trace chart. So application of ridge regression in the daily life is developing medical treatment option for prostate cancer. So there are many forms of cancer which humans contract throughout their lifetime, and prostate cancer is a prevalent form in males. By having an understanding of the variables and measurements which impact the development of the cancer, this will aid researchers in developing medical treatment options. The dataset we will be working with contains various measurements between the level of prostate, specific antigen, and a number of clinical measures in men who were about to receive a radical prostatectomy. Here is a description of the variables within the dataset. Our goal is to develop ridge regression for the LPSA based upon the other variables. First, let's take a look at the raw data in the table. Now let's see if we can further improve upon the MSE by exploring the utilization of a ridge regression model. The first step we will utilize will be to calculate the minimum value of lambda to see in the ridge model. After flexing the boundaries of lambda values, we have determined the lambda of 6.5 would be the ideal value. We should then create a ridge trace to see the convergence of the coefficients to 0. The ridge trace is showing the lambda with a range of 0 to 1000. The next ridge trace shows but isolating the values of lambda between 0 to 10. The ideal value of lambda equal to 6.5 is indicated by the vertical dashed line. The MAC of the model was calculated and determined to be 0.4601. So here is the end of presentation. Thank you.